The enigma of the universe. Every evening as we prepare to rest, we are confronted with one of the greatest mysteries for all mankind, the future. It's the question we can't escape. What will tomorrow bring? We often find ourselves wondering about what the future holds. Will we live the life of our dreams, or will something painful and unpredictable await us? Life is full of uncertainties, and the future remains an elusive puzzle. Most people have at some point thought about what might happen in the distant future, what lies beyond the next few years, or even the next few decades. What would it be like to witness the end of time itself? The question is inescapable. What happens after we die? Death, the most profound certainty of human existence, looms over us all. No one has yet managed to cheat death, and no matter how hard we try to delay it, it will inevitably come. Whether it's the death of a loved one, a natural disaster, or something more cosmic, our existence will ultimately dissolve into the very atoms that once made us. When the sun swallows the earth, when an asteroid impacts our planet, or when time itself fades away, we will return to the very building blocks that once gave birth to life. Our physical forms will vanish, but our atoms, the very particles that once made us who we are, will scatter across the vastness of space. We will return to non-existence, yet the universe will continue its relentless progression. The stars will still rise and set on countless planets. Seasons will change, and tides will ebb and flow. Stars will be born, galaxies will form, and life will continue in ways beyond our comprehension. But as we peer into the night sky, filled with billions of stars, the question remains: why is space so black? If the universe is filled with so many stars, why doesn't the night sky shine with their light? We should, by all logical reasoning, see a sky filled with the light of countless stars. Yet, it's dark. This paradox, known as Olber's paradox, has puzzled astronomers for centuries. The idea is simple. The universe, with its infinite number of stars, should be bright, but instead it's overwhelmingly dark. What's causing this vast emptiness? To answer this paradox, we must go back in time, back to the very beginning of our understanding of the cosmos. Johannes Kepler, in 1610, first proposed a solution. The stars may extend only to a finite distance, and beyond that lies emptiness. The stars, he argued, don't stretch across the infinite expanse of space. There's a boundary to their reach. But this answer only led to more questions. If the universe is finite, what lies beyond it? For centuries, this idea of a finite universe remained a hotly debated topic. Scientists and astronomers alike struggled with the concept of an infinite, static universe. It wasn't until the 19th century that a breakthrough was made. Heinrich Wilhelm Olbers, a German astronomer, re-examined the paradox and proposed that the universe might indeed be infinite, but that the vast distances between stars and galaxies, along with cosmic dust, were obscuring their light. His theory suggested that the darkness was simply due to the scattering of light by dust and gas in space. But this too wasn't enough to explain the paradox fully. In the 20th century, a revolutionary discovery was made that would forever change our understanding of the cosmos. Edwin Hubble, using his telescope, discovered something extraordinary. The universe was expanding. The galaxies were not stationary. They were moving away from each other, and the farther away a galaxy was, the faster it moved. This observation led to the birth of the Big Bang theory, the idea that the universe had a beginning and that it had been expanding ever since. With this discovery came another shocking revelation. The universe was not static. It was dynamic, growing larger by the second. The expansion of space itself is what causes the night sky to appear dark. As the universe expands, light from distant stars is stretched out, causing it to shift into wavelengths that we can no longer perceive with our eyes. The result? The night sky, despite being filled with billions of stars, remains dark. The key to understanding this phenomenon lies in redshift, the process by which light from distant objects is stretched as the universe expands. As galaxies move farther away from us, the light they emit is stretched into the red part of the spectrum and eventually into infrared wavelengths that are invisible to the human eye. This is why, even though the universe is full of stars, we can only see a small fraction of their light. The rest is simply too far away, stretched beyond the visible spectrum. This expanding universe, however, also opens up a new set of questions. How did the Big Bang occur? What caused the universe to explode into existence from a singularity, a point of infinite density? And what lies beyond the observable universe, beyond the stars we can see? The more we explore, the more we realize how little we truly understand. The universe, vast and infinite, is full of secrets. Secrets that we are only beginning to uncover. And with each discovery, new mysteries emerge, pulling us deeper into the cosmic unknown. Yet, despite the vastness of space, one thing remains certain. The universe, with all its swirling galaxies, stars, and black holes, is far from a random, chaotic place. There is an order, a design, a pattern to it all. One that we are only beginning to glimpse. The expanding universe and the hidden forces. As we delve deeper into the fabric of the universe, we realize that the cosmos is far more intricate than we can ever fully comprehend. The expansion of the universe itself, the process that began with the Big Bang, is not just an empty space stretching out. It's an active, dynamic phenomenon driven by unseen forces. These forces, invisible yet immensely powerful, are shaping the universe in ways we never imagined. For a long time, astronomers and physicists believed that the universe was a static, unchanging entity. It wasn't until the 20th century that we began to understand that the universe is not just expanding, it is accelerating. This discovery, made in 1998 by two independent teams of astronomers observing distant supernovae, shocked the world. The idea that the expansion of the universe could accelerate, rather than slow down as once thought, was a profound revelation. The key to understanding this cosmic acceleration lies in something even more mysterious: dark energy. This invisible force, which is thought to make up about 68% of the universe, is responsible for pushing galaxies apart, causing the expansion to speed up. But what is dark energy? How can something so powerful be so elusive? Scientists have been grappling with this question for decades, yet the nature of dark energy remains one of the greatest unsolved mysteries in physics. All we know is that it exerts a repulsive force, pushing galaxies away from each other and speeding up the expansion of the universe. Without dark energy, the expansion of the universe would eventually slow down, and gravity would pull everything back together, possibly leading to a big crunch where the universe collapses back into a singularity. But dark energy prevents this collapse, keeping the universe in a perpetual state of expansion. To understand how dark energy fits into the grand scheme of the universe, we need to look at the larger forces that govern the cosmos. The most fundamental of these forces are gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. These four forces govern everything from the motion of galaxies to the behavior of subatomic particles. But while gravity and electromagnetism are well understood, the forces governing the subatomic world are still a mystery. In the heart of every atom, quarks and gluons interact through the strong nuclear force, while electrons interact with protons through the electromagnetic force. Yet, as powerful as these forces are, they operate only on the smallest scales of the universe. The question then becomes, what governs the behavior of the universe on the largest scales? What dictates the motion of galaxies, stars, and planets across vast distances? The answer lies in the interplay between gravity and dark energy. Gravity, the force that holds galaxies and stars together, works to pull objects toward one another. But dark energy, the force that accelerates the expansion of the universe, works in the opposite direction, pushing everything apart. The balance between these two forces, the gravitational pull that tries to bind the universe together and the dark energy that pushes it apart, is what determines the fate of the cosmos. Galaxies on the move. To understand the true scale of the universe, one only needs to look at the motion of galaxies. We often think of galaxies as fixed entities, but in reality, they are constantly moving. Some galaxies are racing away from us, carried by the expansion of the universe. Others are on a collision course, drawn together by the pull of gravity. The most famous of these impending collisions is the future merger between the Milky Way and the Andromeda Galaxy. This collision, set to happen in about 4.5 billion years, will fundamentally reshape both galaxies, forming a new elliptical galaxy. But even before this massive event, the Milky Way and Andromeda are not alone in the vast expanse of space. They are part of the local group, a collection of over 50 galaxies bound together by gravity. As the galaxies in the local group move, their interactions have a profound impact on each other. Some galaxies will collide and merge, while others will be ejected into intergalactic space, becoming isolated rogue galaxies. This constant movement of galaxies is part of a larger cosmic web, a vast structure that spans the entire universe. The galaxies are not scattered randomly across space. They form intricate patterns like threads woven into a cosmic tapestry. These threads are connected by dark matter, the mysterious substance that makes up much of the mass in the universe. Dark matter acts as the invisible scaffolding of the universe, providing the gravitational glue that holds galaxies together and guides their motion. In the cosmic web, galaxies form clusters, which in turn are part of even larger superclusters. These superclusters are vast regions of space filled with billions of galaxies, all moving in concert with one another. The local group, for instance, is part of the Virgo supercluster, a massive cluster of galaxies that spans over 1 million light-years. And the Virgo supercluster itself is part of the even larger Laniakea supercluster, which contains tens of thousands of galaxies and stretches across over 500 million light-years of space. The mystery of dark matter. While dark energy is responsible for the accelerated expansion of the universe, dark matter plays a key role in the structure of the universe itself. Dark matter is the invisible substance that makes up approximately 27% of the universe's mass. It doesn't emit, absorb, or reflect light, making it impossible to detect directly, but its gravitational effects on visible matter are unmistakable. Dark matter is thought to be responsible for the formation of galaxies. Without it, galaxies would not have the gravitational pull needed to hold their stars and gas together. The stars in a galaxy move at high speeds, and without dark matter, they would be flung out into space. But dark matter's gravitational pull keeps the galaxies intact, holding everything together in a delicate balance. One of the most exciting discoveries in recent years is the detection of dark matter halos, vast invisible structures that surround galaxies. These halos, which are thought to contain the majority of a galaxy's dark matter, extend far beyond the visible galaxy, providing the gravitational force needed to keep galaxies from flying apart. The discovery of these dark matter halos has opened up new avenues of research, as scientists try to better understand this elusive substance and its role in the formation of galaxies. But dark matter is not just a force that shapes galaxies. It also plays a crucial role in the large-scale structure of the universe. As the universe expanded after the Big Bang, dark matter began to clump together, forming the scaffolding for the formation of galaxies, clusters, and superclusters. It is this invisible network of dark matter that gives the universe its structure, shaping the way galaxies move and interact with one another. The endgame. The fate of the universe. As the universe continues to expand and galaxies continue to move, the question remains: what will be the ultimate fate of the cosmos? Will the universe continue to expand forever, or will it eventually collapse back in on itself in a cataclysmic event known as the Big Crunch? Or could there be a third possibility, one that remains just beyond our understanding? Current observations suggest that the universe's expansion is accelerating, driven by the mysterious force of dark energy. This suggests that the universe will continue to grow, stretching out for billions of years until it reaches a state of near-total emptiness. As stars burn out, galaxies drift apart, and the last remnants of matter are scattered across the void. The universe will eventually reach a state known as heat death. where all energy is evenly spread across space and no work can be done. However, the true fate of the universe is still unknown. Some theories suggest that dark energy itself could change over time, causing the expansion to slow or even reverse. Others speculate that the universe could undergo a cyclical process with periods of expansion followed by contraction, leading to a big bounce, where the universe is reborn after each collapse. These theories remain speculative, but they offer a tantalizing glimpse into the future of the cosmos. The cosmic future. Cycles and surprises. The universe in all its vastness continues to unfold in ways we are only beginning to comprehend. As the stars fade and galaxies drift further apart, one might think that the universe is heading toward an inevitable, quiet end. But is the story of the cosmos truly over? Or could something unexpected happen to alter its fate? In the current age of the universe, known as the degenerate era, the stars we see today are reaching the end of their lifespans. The Sun, for instance, is middle-aged in the cosmic sense, with only about 5 billion years left before it exhausts its fuel and transforms into a red giant. But long before the Sun reaches that stage, the universe will already have undergone profound changes. The once vibrant galaxies will slowly fade as stars burn out, and the night sky, once filled with twinkling lights, will become an emptier place. However, there is an intriguing twist in the cosmic future. Black holes. These remnants of massive stars born from supernova and stellar collapse will become the dominant feature of the universe's distant future. Although they are already present in the cores of most galaxies, their influence will grow more significant over time as the universe ages. Black holes are cosmic survivors, able to persist for incredibly long periods, far longer than stars or even galaxies. While the light from stars will fade, black holes will continue to exist, growing larger and more powerful as they consume matter from their surroundings. The Black Hole Era. The black hole era is a time in the distant future when black holes dominate the universe. During this period, all stars will have burned out, leaving only black holes, white dwarfs, and neutron stars. Matter will be drawn into the gravitational pull of black holes, which will continue to grow in size as they consume anything that comes too close. This era will stretch on for an incredibly long time, on the order of trillions of years, before the black holes themselves begin to fade. Black holes are not eternal, however. The Hawking radiation process, proposed by physicist Stephen Hawking in 1974, predicts that black holes will slowly lose mass over time by emitting radiation. Over the course of trillions of years, this radiation will cause black holes to evaporate, gradually shrinking in size until they completely vanish. As the last of the black holes evaporates, the universe will enter its final stage, marked by the slow death of all matter and energy. This final stage, known as the Dark Era, will be a time when the universe is empty, cold, and devoid of any significant events. Stars, galaxies, and even black holes will have disappeared, leaving only a vast, dark void. Even the last remnants of particles like protons and electrons will eventually decay, leaving behind a featureless, silent universe. Yet, even in this ultimate silence, there is a glimmer of hope. According to some theories, the laws of physics may allow for a new beginning. The universe could eventually reach a state where all matter has decayed into pure energy, and from that energy, new universes could be born. The multiverse theory. A cosmic rebirth. One of the most exciting and mind-bending ideas to emerge from the study of cosmology is the multiverse theory. The idea that our universe is just one of many in a larger, infinitely complex structure. According to the multiverse theory, the universe we inhabit is just one of an infinite number of universes, each with its own set of physical laws and properties. These universes may exist parallel to each other, and some may even have different dimensions, creating possibilities far beyond our understanding. The multiverse theory suggests that the end of our universe may not be the end of everything. Instead, it could be the beginning of a new cycle, one in which our universe's final moments of energy decay lead to the formation of new universes, each with their own Big Bang and their own set of cosmic events. This would create a never-ending cycle of creation and destruction, where the death of one universe leads to the birth of another, infinitely regenerating the cosmos. In this scenario, the Big Bang would not be a singular event, but rather a recurring process that repeats across an infinite number of universes. Each universe would have its own path of expansion, life, and death, and while they may be completely separate from one another, they would all follow the same fundamental principles of cosmic evolution. These cycles, some argue, could last forever, creating a universe in constant rebirth. The great cycle of time. Whether the universe will ultimately follow the multiverse theory or some other path, one thing is certain. The universe, in all its grandeur, will continue to evolve in ways that transcend our current understanding. The passage of time, once thought to be linear and unidirectional, could be cyclical, with the end of one universe merely marking the beginning of another. This idea of a cyclical universe suggests that time itself may not be a straight line, but rather a loop that constantly repeats. In this infinite cycle, the universe could experience periods of creation, expansion, collapse, and rebirth over and over again. Each iteration of the cycle would result in a new universe, with new stars, galaxies, and even forms of life. Each unique, but all connected by the same fundamental principles of physics. The concept of the universe as a great cycle is a powerful one, and it mirrors the natural cycles we see in our own world. Life on Earth is defined by cycles, day and night, seasons, birth and death. And these cycles shape everything from the growth of plants to the rhythms of the human body. Perhaps the universe itself follows a similar pattern: creation, growth, decay, and rebirth. The future is unknown, but the journey continues. While we may never know for certain what lies at the end of the universe's journey, one thing is clear. The cosmos is not a static, unchanging entity. It is a living, breathing structure, constantly evolving, expanding, and transforming. The stars, planets, and galaxies that populate the universe are all part of a larger cosmic cycle, a story of creation and destruction that plays out over billions of years. As we look up at the night sky, we are witnessing a universe in motion, one that has been expanding since the Big Bang and will continue to evolve until the very last star burns out. But even as the universe nears its ultimate fate, there is always the possibility of new beginnings, of new cycles of creation and life. The journey of the universe is far from over. It is a story that continues to unfold, full of twists and turns, surprises and revelations. Whether through the slow death of galaxies or the eventual birth of new universes, the story of the cosmos will keep moving, always spinning, always changing. The universe may one day fade into darkness, but in that darkness, who knows what might emerge? The infinite rebirth of the cosmos. The idea of the universe's end, a cold, quiet void stretching out for eternity, has haunted philosophers and scientists alike. Yet despite the inevitability of its fading, the universe's true legacy might not be its end, but rather what lies beyond it. Could it be that what we perceive as an ending is simply the conclusion of one cosmic chapter and the beginning of another? In the last moments of the universe's life, when the stars are no more and black holes have evaporated into the emptiness, the energy from the dying cosmos will not simply vanish. Instead, it may undergo a transformation into something new, a new creation, the seed of a new universe. This idea, proposed by physicists exploring the cyclic model of the universe, suggests that the end of one universe may set the stage for the birth of another in an eternal cycle. The process is theorized to work like this. As the universe approaches its death, it becomes increasingly uniform. All matter will eventually decay into simple particles and radiation, and the energy that once powered stars will be evenly distributed throughout the universe. In the final moments of this era, there may be a dramatic event, perhaps a big rip or a big crunch, a cataclysmic collapse, after which the universe would contract into a singularity, a point of infinite density and zero volume. But even in this state of collapse, the potential for new creation exists. According to the Big Bounce theory, this collapse does not represent an end, but a beginning. The immense energy in compressed matter could trigger another Big Bang, rebirthing the universe in a fresh explosion of energy. This new universe would follow the same cycle: expansion, growth, and eventual death, only to be replaced by a new cycle of creation. The universe, in essence, would never truly die, but would continuously renew itself in an endless cycle of birth and rebirth. The nature of time and the universe's future. But what does this mean for time? If the universe continually bounces back into existence after each collapse, is time truly linear? Could time itself be cyclical, forever looping through the same cycles of creation and destruction? The nature of time is one of the greatest mysteries that science has yet to unravel. In many ways, the discovery that the universe might be part of a larger cycle of rebirth suggests that time itself could be infinite. Just as the seasons repeat on Earth, spring follows winter and summer follows spring, the universe may follow a similar rhythm. The ebb and flow of cosmic time might be as natural as the cycle of day and night. And if time is cyclical, does it mean that the lives we lead, the choices we make, could one day repeat in an infinite loop? Could humanity, in some form, live through the same events over and over, experiencing a kind of cosmic déjà vu? The idea that time, like the universe, could circle back upon itself is a tantalizing possibility, one that might challenge everything we know about life, death, and the passage of time. The great cosmic tapestry. If the universe is in fact reborn in a cycle of eternal renewal, what happens to the matter and energy that once made up the old cosmos? The concept of the cosmic recycling is central to this idea. As stars burn out and black holes evaporate, the material from these celestial bodies is not lost. It may drift into other parts of the universe, potentially influencing the formation of new galaxies, stars, and even planets in future cycles. This constant recycling of energy and matter means that no single event in the universe is entirely isolated. Every star, every galaxy, every living being that has ever existed in the cosmos may, in some way, contribute to future universes. In a sense, every life lived, every star that burns bright, leaves an imprint on the cosmic tapestry, an imprint that may someday be woven back into a new creation. This idea suggests that the universe is far from random. There is an inherent purpose to its motions, a purpose that stretches across eons. The stars we see today, the planets that orbit them, and the life that flourishes on those planets are part of a vast interconnected web of existence, one that transcends time and space. Every piece of this grand puzzle, no matter how small, plays a role in the universe's eternal dance. Humanity's place in the universe's cycle. For humanity, the concept of a universe that endlessly renews itself is both awe-inspiring and humbling. We, as fleeting creatures, are part of this cycle, our lives only a brief flicker in the vastness of cosmic time. But in this brief existence, we have the opportunity to explore, learn, and contribute to the story of the cosmos. The lives we live, the discoveries we make, and the relationships we build. All of these moments, though tiny in the scale of the universe, are part of the cosmic narrative that stretches across eternity. As we continue to push the boundaries of knowledge, striving to understand the mysteries of space-time, dark matter, and the origins of life, we may discover that our place in the universe is far greater than we ever imagined. We may not just be passive observers of the universe's story. We may be participants in its eternal cycle of creation and destruction. Humanity's greatest achievements, our efforts to understand the cosmos, could someday be the seeds for new galaxies, new stars, and new forms of life. As we push forward into the unknown, the legacy of human curiosity and exploration could ripple through time, impacting future universes in ways we can't yet comprehend. A universe of infinite possibilities. In the end, the fate of the universe is uncertain, but one thing is clear: the cosmos is full of infinite possibilities. Even as stars burn out and galaxies fade into darkness, the potential for rebirth remains. Whether through the endless cycles of cosmic expansion and collapse or the birth of new universes, the universe's story will never truly end. It will continue to evolve, expand, and transform, guided by forces that are beyond our understanding. The universe is a place of constant motion, a living, breathing entity that is always in flux. And no matter how many times it dies, it will always be reborn. The cosmic dance will continue, stretching out into eternity, with new stars rising, new worlds forming, and new life emerging from the chaos. The story of the universe is not one of finality, but of eternal renewal, a cycle that will carry on long after we are gone, and perhaps long after the stars themselves have faded. The universe is infinite, and so is its potential. As long as there is energy, there will be motion. And as long as there is motion, there will be life, discovery, and change. The story of the cosmos is one of endless possibility. And though we may never fully understand its mysteries, we are, for a brief moment, a part of its grand journey. The end.